I'm going to talk to you about indirect measurement and how you can use the sun and the shadows that objects cast to help you find the length of an object that would be really tall and hard for you to measure otherwise. But in order to do that, you have to have something to compare it to. So I'm going to give you the example of a person in a tree. Okay, if a person is standing next to a tree and that person is 5 feet tall and they cast a shadow 10 feet long, you can use that to help you figure out how tall a tree is if the tree casts a shadow that's 30 feet long. Now, just so that you are aware, this only works if the person and the tree are standing close to each other, because your shadow length depends on where you are positioned in relation to the sun. So it doesn't matter, you have to be standing relatively close to the tree. That way you guys are that way you and the tree are equal distance from the sun and in the same position, because where the sun is depends on how big your shadow is. But the idea is that the taller the object, the longer the shadow. So you have a tree that's taller than a person, so its shadow is longer, and it's proportionally longer compared to its height. So with that, we are going to set up a proportion, and this is very similar to what we did with similar figures. It's kind of like the triangles you're going to set up, okay? So you've got a person's height. Well, that is like the height of the tree. That corresponds to the height of the tree. So I'm going to set up my proportion this way. Then you've got the length of the shadow of the tree, and you've got the length of the shadow of the person. Those two sides correspond to each other, okay? So now when I'm setting up my proportion, I can say, well, the height of the tree compared to the height of the person is equal to the length of the tree's shadow to the length of the person's shadow. Now at this point, some people can see the relationship between the numbers, and you could pretty quickly figure out what x is. But if you can't, that's okay. You just need to cross multiply and divide to solve the proportion. So 5 times 15 is, 5 times 30 is 150, and then 10 times x is 10x. We divide both sides by 10, and that all cancels out, so we're left with 15 is equal to x. That means that the tree is 15 feet tall. And you can think about it proportionally. This person is 5 feet, their shadow is 10 feet, so their shadow is twice as long as their height. Same thing here. This tree's shadow is twice as long as the tree's height. Okay? Or you can even think about it the different way. This tree shadow is 3 times larger than the person's shadow, so the tree height should be 3 times larger than the person's height, which it is. Okay? Another example is with a person and a house. Don't laugh at my drawings. I know they're not good. We'll even put a little smiley face there. Okay. So again, we're going to see what sides correspond to each other, okay? The height of the person is going to correspond to the height of the house. That's going to be x. And then the length of the person's shadow corresponds to the length of the house's shadow. So when we set up this proportion, we're going to say, okay, the height of the person, which is 6, over the height of the house is equal to the length of the shadow of the person to the length of the shadow of the house. Again, some of you may realize a relationship already at this point between the numbers. If not, you can cross multiply. 10 times x is 10x. 40 times 6 is 240. So now to solve the proportion, we're going to divide both sides by 10. And when we do that, we have x is equal to 24. So that means that this house is 24 feet tall. And again, you should see that relationship, that the shadow here is 1/4 the size of the shadow here. So the person should be 1/4 the height of the house, which they indeed are.